Okay, now we're going to talk about horizontal asymptotes. What a horizontal asymptote is basically when the graph levels off as it gets closer to some point on the x-axis or a value for x. So in other words, your y is going to start approaching a certain value. So what we're going to do is we're going to find the greatest exponent used in the numerator and the denominator. And the greatest exponent is called the degree. Now we're going to compare the degree of the numerator and the denominator. Now, here's how it works. If the degree of the numerator is greater than the denominator, this is what I call top-heavy, then you have no horizontal asymptote. If the denominator is bigger, then the function's graph has a horizontal asymptote at y equals 0, or the x-axis. What happens is if there's a tie, so here we have a tie, if there's a tie, then you're going to divide the coefficients. And remember, the coefficients are the numbers in front of the variables. So let's look at how we're going to use this. If you look at the first one, it says f of x equals 3x squared plus 7 divided by 5x squared plus 8x minus 1. So find the degree of the numerator, and the degree is a 2, and on the bottom we also have a 2. Well, now that we have a tie, so this is what we'd say a tie, my horizontal asymptote would actually be y equals the coefficient of 3 and 5. So it would be y equals 3/5. Now if I'm going to find the range, my range of this graph would be all real numbers, but y cannot equal 3/5. For the second one, notice the power of the top is a 2, and the power of the bottom is a 3. And now that I know that the bottom is bigger, this is what I would call bottom heavy, then my horizontal asymptote will always be y equals 0. So that means if I'm finding the range, it would be all real numbers, but y cannot equal 0. Now for the bottom one, now for the last one, notice my biggest power is on top. So I have the highest degree of 2 on the top, and the bottom, my degree is 1. So since I am top heavy, this right here would have no horizontal asymptote, which means our range, since I don't have any restrictions, my range would be just all real numbers. Now when we're looking at graphing, basically what we want to do is identify where your asymptotes are. That's probably the most important part. Now, vertical asymptote will always set the denominator equal to 0. So to get my vertical asymptote, I'm going to set x minus 4 equal to 0, and I'll get x equals 4. So my vertical asymptote, if I find 4, basically I'm going to draw a dotted line to the best that I can going through x equals 4. So there's my vertical asymptote. To find the horizontal asymptote, notice I'm in a transformation setup. Well, this plus 3 is going to move everything up 3. Well, normally my horizontal asymptote is here at y equals 0. What's going to happen is that plus 3 is going to move it up 3. So my new horizontal asymptote will actually be up here. So when I do that, I'm going to draw a horizontal line going through y equals 3. So I'm going to say my horizontal asymptote is y equals 3. And now when I graph it, since there is no negative, then I know my graph's going to look something like so. And you can use your graph and calculator to kind of confirm that. But as far as domain is concerned, my domain will be all real numbers, but x cannot equal 4. And for my range, it would be all real numbers again, but y cannot equal 3. So, now we're going to look at number 9. Number 9 basically says that since it's not in transformation setup, what we're going to have to do is still find a vertical asymptote the same way. So I set the denominator equal to 0 and solve for x. Subtract 2. I get 2x equals negative 2. Divide both sides by 2. And I get x equals negative 1. So there's my vertical asymptote. So I'm going to find negative 1, draw a vertical line going through it, or a dotted vertical line going through it. Now to get the horizontal asymptote, I look at the powers. Notice my powers are equal, or is degrees. I have a first degree on top, first degree on the bottom. So then my horizontal asymptote will be the ratio, so negative 3 over 2. So once again, I'm just looking at the degree of the powers. When I do that, I'm at negative 1/2. So now when I make my graph's going to go something in this nature where it falls down to the left, then does the same thing going to the right, but we get really close to that asymptote. So domain would be all real numbers, but x cannot equal negative 1. Because negative 1 did not work for the x's. Here's negative 1. As far as range, it would be all real numbers. However, y cannot equal negative 3/2.